In 2012, 3.6 billion tons of cement were produced worldwide. That amount is more than all the food produced for human consumption that same year. We mix most of the cement with about 22 billion tons of aggregates and 2.5 billion tons of water. This makes concrete the product most consumed by humans. We use it to build homes, bridges, and other infrastructure we use every day. The reasons concrete is so popular is because it is cheap, made of widely available materials, and easy to use. But the global demand for concrete requires huge amounts of resources. And we are going to need even more. By 2050, the cement consumption is expected to double. Look at how China alone is already consuming more cement than the whole world in 1990, and how India's cement production has doubled over the past 10 years. It will be a real challenge to meet the projected demand. Compared to many other materials, producing cement is very ecological. But with several billion tons produced each year, the cement industry is a major contributor to global CO2 emissions. Where does it come from exactly? To manufacture cement, limestone and clay are heated together in a large kiln at about 1450 degrees Celsius. This produces an intermediate material called clinker, which is rapidly cooled, mixed together with gypsum, and ground to make cement. 40% of CO2 emissions come from burning the fuels needed for the kiln. The efficiency of this manufacturing process is already optimized in most modern cement plants. But we can act on the 60% remaining of CO2 emissions which come straight from the decomposition of the limestone. How, you ask? We can substitute part of this clinker by less CO2-intensive materials, called supplementary cementitious materials. We often throw in waste materials from other industries, for example, blast furnace slag from steel plants or fly ashes from coal-fired power plants. What you get is a blended cement. Sadly, there are not enough substitute materials for everyone. So what other substitutes can we use? When calcined at a temperature of only 800 degrees Celsius, clay becomes reactive and can be used as a replacement material. We can also add limestone without any heating. Simply grind it and voila! We know how to use them separately, but if we add both of them to clinker, there is a synergy between the components, and you get a perfectly good cement even with high additions. This is where LC3 comes in. LC3 stands for Limestone Calcined Clay Cement. It is a special blend composed of 50% clinker, 30% calcined clay, and 15% ground limestone. With 50% of replacement, we can double the production of cement with the same amount of clinker. Better yet, we can use limestone and clay of lower grade normally discarded by industries. No precious agricultural soil or topsoil will be used. Also, clays are abundantly available in regions where the highest cement consumption is expected. LC3 aims to provide local solutions to the global demand. This new material is very attractive.
Is it?
Sure. It is low carbon. Up to 50% of the clinker can be substituted. The limestone doesn't need to be heated and the clay is activated at low temperature. It is low cost. Cheap, low-grade materials can be used. Limestone and clay are widely available from existing quarries and easily extracted, within the first 5 meters of the Earth's crust. It is low capital. Increasing production with LC3 requires less investment than adding a new production line. Simply adapt an existing kiln or buy a cheap one for the clay. And the best part is, LC3 is easy to use. You can replace a normal cement bag by a LC3 bag. You get the same handling, same procedure. Before LC3 can be mass-produced, it needs to be certified according to industry standards. This is why LC3 has become a large-scale project. With scientific partners in Switzerland, India, and Cuba, many industrial partners around the globe, and the support of the SDC. Given the great advantages of LC3, we have the full support from the industry to show its easy handling, its easy casting, its strength, and its durability. As a group, we are all working full speed to make cement more sustainable. And as always,
Thanks for watching.